Section 2.2 talks about measures of location. It introduces the lower quartile as being 1/4 of the way through the data set. Talks about the upper quartile as being 3/4 of the way through the data set, and also introduces the idea of percentiles. So the upper and lower quartiles are percentiles themselves, the lower quartile being the 25th percentile, the upper quartile being the 75th percentile. We will talk a little bit more about percentiles in the next example, but for now we're going to focus on the lower and upper quartile. This definition here kind of helps us for discrete data. So, if we had n bits of data, in order to find out the location of the lower quartile, we would divide that n by 4. If we end up with a whole number, to find the lower quartile, we need to find that bit of data and the next bit of data, and the lower quartile would be the bit halfway between those two. For example, if I had 40 bits of data, I'd divide that by 4 to get 10. Therefore, the lower quartile would be halfway between the 10th and the 11th bit of data. If I maybe had 43 bits of data, I'd divide 43 by 4 and I would get 10.75. Now, if it's not a whole number, which 10.75 isn't a whole number, we need to round it up and pick that bit of data. So rather than using 10.75, we would use the 11th bit of data. That would be our lower quartile. Now, even if I had 41 bits of data, dividing that by 4 would give me 10.25. Now, you may feel like you would round that down and use the 10th bit of data, but as this definition says, we round it up. So even if it was 10.25, we would round that up and use the 11th bit of data. So that's very, very similar for them finding the upper quartile, but rather than 1/4 of n, we are finding 3/4 of n. And the idea of being a whole number and not being a whole number is the same for the upper quartile. Okay. So, as this is take 2, I've already done my working out, so I'll try and hide it from you and talk through as I go. Example 4 talks about the large data set, and it gives us the daily maximum gust, and it gives us the first 20 days of June 2015 from Herne. The data is shown below, and we want to find the median and the upper and lower quartile for this data. So, very nicely set out, because the data is first of all in order, but also split in half. So it makes it really easy for us to see that the median value is going to be halfway between 22 and 23, which is 22.5. However, if you wanted to see a similar method for working it out using those definitions, we would look at doing 20, which is the number of bits of data, dividing it by 2 because it's our Q2 or our median or halfway, we would get an answer of 10. Now, because that's a whole number, the bit of data that we need is going to be the bit of data between the 10th and the 11th value. Therefore, the 10.5 bit of data, which is 22.5, 10.5 bit of data being halfway between the 10th and the 11th bit of data. And then seeing this working out in a similar context for the lower quartile, we would do 20 divided by 4. It gives us 5, which is a whole number. Therefore, we're not looking for the 5th bit of data. We are looking for the 5.5th bit of data. So we are looking for the bit of data that is halfway between the 5th and the 6th bit of data. So if I can count this correctly, we've got 1, 2, 3, 4, 5, and then the 6th, and halfway between 18 and 18 is still 18. Okay? And using that calculation for the upper quartile, we need to do 3/4 of 20, which gives us 15. 15 is a whole number, So we're looking for the bit of data which is between the 15th and the 16th bit of data, which is the 15th and a half bit of data. And as this spoiler arrow probably showed you straight away, this is going to be where our upper quartile is going to be. So we've got the first 10, we've got the 11th, 12th, 13th, 14th, 15th and 16th bit of data. We want the 15th and a half bit of data, which lies between these two, which is 25 and a half. So that is how we would calculate our quartiles and the median using that new rule from the page before.